everyone, and welcome to today's crash course on the periodic table of elements. So this concept is divided into two parts and is meant for secondary for students that are following the ST program. So in the first part today, we're going to be talking about the periodic table of elements, how it's organized into periods and to groups. And then part two, we're going to talk about the squares in the periodic table and how Lewis notation and the Rutherford-Bohr atomic model are drawn and used with the periodic table. So let's start things off. So what is a periodic table of elements? Well, it's basically all the chemical elements that are organized into rows and columns. So here we have 118 of them, and they are organized based off of the composition of their nucleus as well as their electron configuration. So let's have a look at the structure of the periodic table. So first, the elements are organized into horizontal rows, and in the periodic table, the horizontal rows are called periods, and there are 7. But the thing that's really important to remember is that periods 6 and 7 are continued at the bottom here. See these two rows? And so periods 6 and 7 actually have 32 elements, but they moved those two rows down below because 32 elements in one big row would just be too long. So let's do a practice question. Which period does iodine belong to? Is it A, period 2, B, period 3, C, period 4, or D, period 5? The answer is D, period 5. So the chemical symbol iodine is in period number 5. Now remember, periods are our horizontal rows. So we're going to go down to period number 5, and then we're going to go across until you reach the chemical symbol I. And there you have it in period number 5. So not only does the period number help us locate a chemical on the periodic table, but the number is actually quite important. So 1, 2, 3, 4, 5, 6, and 7, we have 7 periods. Each one of those numbers tells us how many electron shells there are in that element. And it's based off of their energy level. So for example, lithium is in the 2nd period, which means it has 2 electron shells. If we look at calcium, it is in the 4th period, meaning it has 4 electron shells. And we're actually going to look at that in video number 2 when we talk about the Rutherford-Bohr model. But just so you remember, electron shells, like right here, really important to keep in mind when we talk about periods. So now that we've looked at the rows, we'll look at the columns. And the columns are actually called families or groups. And so in this video and in your secondary for ST Lives, we're going to look at the first 2 groups, the first 2 columns, and then the last 6. And so we're going to be using those throughout our next example. So let's do a practice question. Which group does silicone belong to? Is it A, group 3, B, group 4, C, group 4A, or D, group 4B? And the answer is C, group 4A. So to answer, simply locate silicone, the chemical symbol Si, and then follow the column all the way up until you reach the Roman numeral section at the top of the group, which is 4A. So elements found in the same group often share similar characteristics, and one of the most important of those are their valence electrons. And so the number, the Roman numeral at the top of the columns that we've been talking about, the top of the families, the groups, that represents the number of valence electrons that are found in each of those elements. So for example, if I want to take sodium, it is in group number 1A, so that means that it has 1 valence electron. If we look at carbon is in group 4A, so it means it has 4 valence electrons. And so that is crucial when we do Lewis dot notation as well as the Rutherford-Bohr model. And we're going to jump over to that in video number 2. But first, let's put this into practice. How many electron shells and valence electrons does phosphorus have? Is it A, 3 electron shells, 15 valence electrons, B, 3 electron shells, 5 valence electrons, C, 5 electron shells, 3 valence electrons, or D, 15 electron shells and 3 valence electrons? The answer is B, 3 electron shells and 5 valence electrons. So you just have to remember that our periods, which are our horizontal lines, represent our electron shells, and that our groups, which are our columns, represent our valence electrons. And so if we find phosphorus, which is over here, and it has the chemical symbol P, If we go across, we notice that it has an electron shell of 3. And then if we look up, it has 5 valence electrons, which will help us when we look at Lewis dot diagrams and Rutherford Bohr diagrams in video number 2. So there are 4 groups or families that you should be aware of, especially their names and their properties and the elements that compose that group. So the first one, remember, groups are our vertical lines here. Our first group is group 1A, and they are called the alkali metals. Now it's important to note that hydrogen, which is a yellow, we have a yellow here, it belongs to the gases on the other side. So it is not part of an alkali metal, the column there. Our alkali metals start with lithium. And so it's really important to know that they have 1 valence electron, right? Because they are in that group 1A. They are highly reactive. So they're often stored in oil because if they touch air, they explode, especially with acids, water, elements from group 7A. They have a tendency to react. They are highly malleable, highly ductile. They contain a lot of the properties of metals. So they are good conductors of heat and electricity. They are shiny. So just keep that in mind when we talk about alkali metals. So the next group or family is the alkaline-earth metals, and they are in the second group 2A, which means they have 2 valence electrons, and they are called the soft metal reactive metals. And so they are very reactive as well, especially with acids, water elements, and group 6A and 7A. So they have a tendency to mix and then react. Again, we are talking about metals. So they are malleable, they are ductile, they are good conductors of electricity and heat, and they have that shiny luster to them. So just keeping that in mind, that everything in column 2A is an alkali earth metal. Our third family is called the halogens. So they are in the second last column of our periodic table. And what's cool about the halogens are that they are not found in their original pure state in nature. We can't find them that way. But another thing that's cool about them is because they are in that column 7A, they have 7 valence electrons. They are also, again, highly reactive, especially with water to form acids, and with alkali and alkali earth metals to form salts. So they like to react with our column 1A and 2A. What's also cool about halogens, they are often used for their disinfecting properties. So one of the best examples of a halogen is chlorine for pools and that kind of thing. And finally, our fourth family or group is called the ennoble or inert gases. So these are the least reactive of the bunch because their valence electron shell is full, meaning they can't bond with other elements, so they are the most stable. So remember that helium is special. It has 2 valence electrons, but all of the other ones have 8. Because it's the last electron shell that's full, as I mentioned before, and they are also in the 8th group. They are not reactive, as I said, and noble or inert implies that name. They are colorless, odorless, tasteless, and non-flammable types of gases. And so that brings all of our families to our periodic table. So there you have it. Part 1. So in this video, remember we talked about the periodic table of elements, its structure. We talked about periods, which are our rows, and how they represent the number of electron shells per element. Then we also talked about our groups, which are our columns. Then we talked about the number of valence electrons that entails with the Roman numeral at the top of each group. Then we have our alkali metals, our alkali earth metals, our halogens, and our noble gases, which are 4 families that we know about, and we know their properties and their characteristics. So remember, if you need to rewatch this to practice, please do so. Otherwise, hop on over to part 2 and we can talk about Rutherford Bohr and the Lewis notation.